This is the video notes for 9.2c, correlation coefficient. The correlation coefficient is represented by the letter R. What does it tell us? It tells us the magnitude and direction of the relationship between the two variables that we're comparing. So, magnitude and direction of the relationship between the two variables. We use words like a strong correlation, or moderate, or weak, or positive, or negative correlation in order to describe the relationship, the magnitude, and the direction of the relationship between our variables. How do I find the correlation coefficient? So we're actually not going to use our handheld calculators. We're going to use Desmos. So these directions I'm going to cross out. I'm going to add in some directions on how to use Desmos, the online graphing calculator. Okay, so let me go over here to this white space. Find some space on your page to write this down, please. So go to desmos.com/calculator. And then the first step is to use the little plus symbol, upper left, to add a table. And you're going to add the table of all your data. Add table of all your data. Once you've done that, then you go to the next line below your table and you add an equation. That uses the table. And it's going to be slope-intercept form, but there are some changes to it. It's going to be y1 tilde mx1 plus b. So it's pretty much y equals mx plus b, but the tilde, the little squiggly line, tells it use the table to do calculations. Once you've typed that in, then it'll actually give you the slope and the y-intercept of a line of best fit that goes through your scatter plot data. You also probably want to adjust your scale. To do that, you go to the little wrench. And I would always set your lower boundary for x to be 0 and your upper boundary a little bit bigger than your largest x value. So bigger than your largest x value. And then for y, you'll do the same thing. And lower limit 0, and then upper limit bigger than largest y value. What you'll notice when you do this process is they'll give you a lot of information. Not only does it give you m, the slope, and b, the y-intercept, so m and b, but it gives you something called r. For now, ignore r squared and e. Instead, just focus here on r. So our r for this problem that I had in there was 0.97, which is an excellent r value. That means the data is very close to being linear. It has a really strong correlation, a really strong relationship. Let's show you what the picture looked like for there we go. This is what the image looked like for that R value. So you can tell that, oh yeah, the data is very close to the line. There's a very, very tight, close correlation, and it's positive. See that it's positive? So let's fill in some of the blanks over here on the right. Let's fill in, what does it tell us? The sign and absolute value of R describes the direction and magnitude of the relationship. The value of a correlation coefficient ranges between -1 and a 1. There's nothing above or below those. The greater the absolute value of a correlation coefficient, the stronger the linear relationship. Okay, as you can see on the example that I brought these pictures in, 0.97, those points, the scatter plot dots are so close to that straight line. The strongest linear relationships are when R is -1 or +1. The weakest relationship is when R is 0. Positive correlation means as one variable gets larger, the other one also gets larger. A negative correlation is the opposite. When one variable gets larger, the other tends to get smaller. The correlation coefficient and the slope of the regression line have the same sign. Okay, so that fills in all the blanks. Let's just talk a little bit about this diagram here, and then we'll be good. So if we look at this first picture right here, that is a very strong negative correlation because it's very close to -1, negative 0.95. You can tell that the points are almost forming a straight line, linear, all on their own. This next one here, negative 0.6, there's generally a trend. I would say it's moderate, maybe you can call it even weak, but we do see it, and we generally say that it's negative, it's going down, so you could say moderate, negative. This middle one here, where R is about 0, I would say no correlation, because the data is just spread out. There's no way I can put a straight line through that. R is positive 0.6. It has a positive, moderate correlation. And then over here, R is 0.95. That would be a strong positive correlation. I hope this was helpful. I wish you best of luck on your practice.